Hello, welcome to You Choose, where we choose our own adventure through the whole CNCF landscape. Or rather, you do, you the viewer. Victor and I are determined not to choose anything. We're doing our best.
Speak for yourself.
Yeah, what are you choosing over there?
In general, now I'm hearing for the first time that I'm not allowed to choose. Come on.
I thought that was the point. What do you wish you could choose that you haven't chosen?
Huh?
What do
The
you
last
wish
one
you?
I chose right, so that's fine so far in this series.
Oh, so when you vote, you're talking about we vote for the
Yeah,
technologies.
of course. I'm not
Yeah,
gonna let
yeah.
things be decided by others. Come on.
I vote too, but I always vote for who's losing. I'll even change my vote to make sure to help everyone feel good.
That's fine. That's fine. The loser from last week has 2 votes instead of 1. Now I get it. Okay. That explains it. That explains it. You and whomever was our guest. Excellent. That
Probably.
makes sense.
Oh, that's too funny. So we skipped a week because last week was PromCon or Prometheus Con. So at first we were doing this episode today about open standards. And then we're like, oh well, we'll just flip it with the next episode. But the next episode was metrics, so it's like, oh, you know what? We're just gonna postpone a week so that we can make room for all of our everybody. Victor, I'm concerned that we don't have any comments yet. Are folks here? Will you say hello to us, please? So we know you're there and can see and hear us. I am really excited for today's episode. We have 2 super duper wonderful guests. Hello. Okay, someone said hi in the chat. Thank you. We have 2
That's
super duper
extorted. That doesn't count. That was under extortion. Come on.
I was legitimately concerned. We have 2 super duper wonderful guests, Austin and Richie. And what is also great about them is they're very opinionated. So I think we're going to have some spicy discussion. And I'm already excited for that. But first, we're going to recap what we went over last week. So last week we talked about dashboards, and specifically we talked about Kubernetes dashboards, not observability dashboards. I think that's an important distinction. We went over 3 different tools: Kubernetes dashboard, Headlamp, and Meshery. So tell us about Kubernetes dashboard, Victor.
It got 2 votes. And I know who that is. That's all I need to know. I mean, it's one of the first, if not the first, Kubernetes dashboard. Basically, it's done by Kubernetes community itself. It's one of the Kubernetes projects, all right. And then
And it's
new dashboards with potentially new ideas emerged afterwards.
Yeah, it's very close to the Kubernetes APIs. I understand. It's just like Kubernetes visualized. There's no bells and whistles. There's not even like no different views for different personas. No RBAC even, really, I understand. So it's you can just see everything. It's Kubernetes APIs visualized, which is actually wonderful if you're trying to learn Kubernetes. That'd be a great way to help you drive the concepts home. But
so you're saying that you're learning Kubernetes, Whitney, through dashboards and not kubectl or kube control. Is that what you're saying?
That's
not too late.
That's not what I did, but I can see value in that idea. Not only that, mostly kubectl, but some of each certainly. And then, so that's a recap of Kubernetes dashboard. I know we sold you on that one. The next one is Headlamp. Tell us about Headlamp, Victor.
Headlamp. I mean, they all share the same base, and that's, hey, this is how you can see namespaces and pods and deployments and what's or not, right? It looks differently, different colors. The big difference, at least from my perspective, is that you can extend Headlamp, right? So you can it has some sort of plugins, right? So you can extend it for your needs, and then it shows beyond. It could show beyond the usual Kubernetes stuff, right?
Yeah. So I got corrected. I want to point that out. There's definitely RBAC with Kubernetes dashboard. So there we
Yeah.
go. Okay. And so Headlamp, it's extensible, same thing.
Extensible, yeah.
Extensible, and it.
Whitney, if I need to teach you English, we're in deep trouble.
And so that's a big thing. It's also adaptive UI. So if you can't edit a resource, then the edit button won't even be there. And then you extend it with plugins, and it can also be like packaged and distributed across your organization. So you could have like organization specific way, like plugins that you're using, but then as an individual user, you could add plugins that might help your particular experience. And so baseline is like cluster level viewing, but you can add those plugins to help you have application level observations into what's happening in your cluster. And what they're trying to do too, which I learned, which seems pretty cool, is they would like to be the UI for the other Kubernetes projects that don't yet have a UI. So they're trying to offer an extensible way for other projects to be able to have a web UI. So I think that's nice. And then the last one we talked about last week was Meshery. What's your take on Meshery?
I still did not figure it out, so I still need to go deeper into it. It has the same features like other dashboards. You can see pods and deployments and so on and so forth. But there's a bunch of other things which, to be honest, I haven't went into yet. So I'm not that experienced with beyond the ordinary part of it.
I think the way Lee put it is that it's management software more than simply a UI. So for one thing, the scope of it's bigger. It can do multi-cluster, not only multi-cluster, but it can like help you visualize stuff that's like cloud resources only. That's completely outside of Kubernetes. But then in the management part, he talked a lot about collaboration. Like it enables you to be able to collaborate, like have a single source of truth that's visual. And then he made this analogy of like, it's like when you're working on a certain design or a certain resource in Meshery, it's similar to working on a Google Doc where you could see other people in there viewing it. You can make suggestions or comments on how things are or how you think they should be. You could say, I want to make this change, and someone else has to approve the change. Like that sort of communication around what's actually happening, which seems it's interesting. It's definitely more than a UI. Feels supercharged, but yeah, the use cases.
It's not more than a UI. It's more than typical dashboard. What typical dashboard? It is a UI, so it cannot be more than what it is.
Just because it's like
the scope
click
of what it shows is more. Yeah.
So the definition of a UI is that it's something you click on.
Colors, pretty colors,
and you use your mouse and
is.
yeah.
Click, exactly.
Click in colors. Okay. It's definitely that. And then he also talked about like using it for performance testing and like being able to experiment with different configurations and different tools before and generating load and recording metrics and comparing those as part of what it can do. That's it. Is there anything else you want to say about dashboards, dashboard tools?
No, this is, typically I have very strong opinion about the tools in every category you pass, but I don't use much dashboards myself, so not many comments. Kind of, I'm a terminal type of guy.
You look like a terminal type of guy.
That's not a compliment, but I'll roll with it. Okay.
Who won, Victor? Who got chosen? Who got chosen?
The headlamp, I think.
Headlamp.
Here's the picture. Yeah, headlamp. Yeah.
Oh, goodness.
And I have it here, so I can show you headlamp. This is going to be the fastest demo ever. What are you doing with me? Come on.
I got excited.
There we go. If you can share my screen, I can show headlamp. And as I said,
your screen isn't shared right. Yeah.
It's not shared. Oh yeah, because I restarted. There we go. Let's share the screen. Oh, open system preferences. You see, you should really do this. Google Chrome, yes. Password. Typing it. Quit and reopen. I need to quit.
I
I'll be
have.
back.
Oh no. Okay, I have a joke. Um, what's red and bad for your teeth? A brick. Huh? Okay, this is terrible. Victor, come back. I can see. What else did I get? Why did the man fall down the well? Because he couldn't see that well. This is Victor's fault. I'm going, aha. Victor, I was telling jokes. It was terrible. Nobody was making it. Aha, I got one comment.
Here I am present. Let's see whether it works now. Share screen. Yes. Entire screen. Yes. There we go. There we go. Now I'm sharing my screen. This is the right screen. This is Headlamp. And
Headlamp.
as I promised, it's going to be brief. You can click and see the namespace cluster, right? CPU, memory, pods, what's a node. And then you can see namespaces, and then you can see nodes, and then you can see custom resources. And if it ever loads, eventually we'll see custom resources. And you can see workloads and pods and deployments. Basically, this is what you expect from almost any dashboard. Basically, you can see all different Kubernetes resources. The nice thing is that I'm not sure whether they're all showing custom resources. That might be slightly special, but generally speaking, you can see all the Kubernetes types of resources, right? And then on top of that, which I didn't do today, you can, as we mentioned before, extend it and do some special screens that are special to you, or use plugin from one of the other people from the community, right? But if you exclude the exceptions, the extensions or plugins, this is pretty much you can see stuff.
What are the plugins discoverable? How do you find the plugins?
By Googling. What do you mean? How do you find anything with me? Come on. Are you in Yahoo still? What's going on? Bing. But binging it.
We have a question. What's the point of it? It sounds like a Kubernetes dashboard. But the point is that they're plugins that you can see all kinds of things. Plus, it has an adaptive UI, so it's more.
Yeah, so it's arguably nicer, better organized, slightly more, not much, but more attention is put into making it more user friendly. Let's say.
More user friendly, and you can also see application level. You could see with using plugins. You can see. There's a Prometheus plugin. You can also see how applications interact with each other, or more detailed application level stuff. Exactly. Here's a question for you, Victor. Can you install it from the manifest, or do you use Helm? How do you install it?
I used Helm today, but you can install it any other way. In a worst case scenario, if you can always do Helm template to convert it into pure YAML and then install it like that.
All right.
But yeah, it's manifest one form or another.
That's Headlamp. It's nice. I like the logo. I like the pixely. All right. So here we are. Here we are. We're going to talk about open standards. Up top, we have to tell you there's not going to be a vote today. Why not, Victor?
Because there is nothing to vote, right? You are going to be most likely using both of those, and we are not talking much about tools today, even though some standards come from some tools. We're not talking about tools. We will be talking about tools next week. Today we are talking about standards, and frankly, if you don't use both of them, then you're doing something wrong probably. Anyways, so nothing to vote.
So we're talking about today, we have one guest representing OpenTelemetry and another guest representing Prometheus. And each of those things, I kind of thought I knew what they were before we went into this observability chapter, but they're both actually a lot more than what I realized. So they each have a specification element. They each are standards. and they each are software. And so my first question is, what's the distinction between a specification and a standard?
I mean, I can create a specification now while people are speaking, and it's not going to become a standard. It's not likely to become a standard, right? So again, the way I see it, at least, standard is something that is widely adopted, right? Or this, standards can be decided. A government can decide this is standard, ISO or whatever it is, right? So somebody can decide it's a standard, or it can simply become a standard by adoption, right? So not every specification is a standard.
Is every standard a specification?
No, not every specification becomes a standard.
Not every, yes, I heard that. If it's a standard, did it come from being a specification, or you have standards that are not specifications?
Yeah, I mean, you can say that, for example, from certain perspective, you can say, and I will disagree with that, but you could say that Helm is a standard, right? And it's not necessarily a specification of anything, right? It's Go templating wrapped around a few other things, right?
Gotcha. And so coming into learning about observability and learning about these tools, I definitely felt, and maybe still feel, some confusion around what they are exactly in terms of, because even when we say they're software, they're actually, each one has many different components of the software element in terms of what it can do. So that's one thing I'm going to ask.
Especially OpenTelemetry, right? It started, and speakers can correct me afterwards. It's first and foremost a specification. It started like that, and then it got implementations which you might or might not use from the project itself. You can use implementations from elsewhere and so on and so forth, but it's first and foremost standard, right? While Prometheus, and I might be wrong, feels like it's as much one as the other, right?
Prometheus maybe started more as software that then built standards around it, or specifications around it, excuse me.
I feel that it became a standard by people adopting the software more than anything else. And then through that adoption, we got a significant number of the tools that we are using today rely on Prometheus. Not necessarily exclusively, but rely on it. Like, for example, if you're going to scale your applications based on anything but memory and CPU, you're most likely going to hook it into Prometheus query that comes from Prometheus or elsewhere, right? Does not necessarily have to come from Prometheus itself.
So Prometheus query language, or PromQL, is maybe one of the specifications around Prometheus. Yeah, that's one of them. In terms of like the format, probably, that the metrics are in, would be one of the specifications.
That's more format for querying, and then there is a format of metrics, how they're ingested into
maybe
the database.
Maybe how they're generated. This is the part where we have super duper experts backstage, and Victor and I fumble our way through what these technologies are. But let's talk about one more thing before we bring our experts on, and that is, like, why do we even care about standards, like standardization or specifications? Like, why is
you
this
start
important?
with the assumption that we care. I'm kidding, of course. I mean, I think that guests can explain it probably more, right? But there is two-part answer, right? Why do you care as a vendor who is building software somehow related to observability, right? And especially, why do you care as a user, right? Especially to me, the most interesting part is not necessarily how much I care about this personal, right? How much I care whether it's this standard or that standard for third parties, but I especially care about what is the standard that I need to use or what is the format I need to use to instrument my own application, because that's investment on my part, right?
Yeah.
And I definitely don't want to lose it if I switch from one to another.
Yeah. So being able to have all of your tooling play well with each other, regardless of who made it, is an important part of important reason that standards are important. I just said important twice in the same sentence, but I'm just really driving it home. So I think it's time to bring some experts on. But Yes. If y'all have questions, especially after what Victor and I just talked through, please don't be shy with the questions. Put them in the chats. Well, we do have a question and answer part of the show later after our experts present. And the sooner you ask the question, the more likely it is to get to our experts. So first I'm going to bring Richie H on. Hello, Richie. Thanks so much for being here. Will you introduce yourself, please?
Hello. Thanks for having me. I'm Richie. I'm a Prometheus team member. I've also been a voting member of OpenTelemetry twice already, so sitting on both sides a little bit. I work at Grafana.
You're infiltrating the other team.
Infiltrating
we
the
are
other
trying
team.
to make certain that interoperability actually works, because else the user and the wider CNCF ecosystem have a major issue. So we just have to. But yeah, like my contributions to OpenTelemetry are solidly on the interoperability with Prometheus side of things. Yeah, as I said, work for Grafana. I organize various conferences from FOSDEM to PromCon to others. Yeah, that's me.
Awesome. Well, we look forward to hearing your presentation here in just a little bit. Thank you, Richie.
Yeah.
Austin, welcome. Hello. Will you introduce yourself, please?
Hello, Internet. I'm Austin Parker, Director of Open Source at Honeycomb.io. I'm one of the founding team members of the OpenTelemetry project and a former maintainer on OpenTracing. I also serve on the governance committee for OpenTelemetry, which is sort of like our steering committee equivalent in the Kubernetes world. And I do a bunch of other stuff. I've written a couple books on the topic. I help organize a lot of OpenTelemetry community events. And, do a lot of advocacy and public education on the topic of observability, distributed tracing, and open observability.
Amazing. Thank you so much for sharing your time and expertise, and we'll see you shortly. So Richie's going to present first, but based on what Austin just said, he mentioned open tracing. I know if Whitney 4 months ago heard that, I'd be like, oh my God, there's another one. But open tracing predates OpenTelemetry and is part of what is now OpenTelemetry. So just if there's any noobs like me out there, I just want to give you that context. And now we have Richie here with us. I'm the timer today, so I'm going to set the timer and then I'll get you going. Here we go. Start.
Okay. So we've been challenged to try and get to the 5 minutes and see if they cut us off, and apparently they will, which is fun. So looking forward to that one. Yeah, maybe to start at the beginning, I was honestly kind of amused by the discussion about specification versus standard, and the two ways you can go. Anything Prometheus will sometimes start a design document, but speaking as a former networking person, IETF is like the gold standard here. Working code wins, and that's one of the maxims of Prometheus. Unless you have working code, you're not progressing. And that's different to other things in software, but Prometheus always values something which is actually working and testable and provable and long-term stable over pretty much all the other considerations. For those who don't know, Prometheus is a metrics storage, a so-called time series database, as in recording data which changes over time. And the software part of Prometheus starts at the instrumentation, as in code which you add to your own software, or exporters, which is basically reverse proxies which rewrite data from whatever format into something which Prometheus can understand, to optionally a pipeline component to the storage and long-term storage and querying and everything in between. Like, you have the complete stack for your metrics. It is highly aggressively optimized for performance. And you will have a hard time finding other things which are as efficient as Prometheus in pretty much anything, both on the emitting side and on the transmitting side and on the storage and querying side. Which, for example, is the reason why within Kubernetes you have kube-state metrics, which is a friendly fork of the Prometheus code base to emit all the metrics. And there we are at the open standards and such, because Prometheus is the de facto standard within CNCF and has been for basically since CNCF existed. It is the second project to ever join CNCF. And even though Kubernetes and Prometheus were completely developed out of scope of each other through the shared history of Borg and Borgmon, which initially come from Google. They have always been kind of designed for each other, even though the people actually writing the software didn't know the other thing existed. Speaking of the efficiency and everything, and we'll see how Parker has a different stance here by necessity. Prometheus is very, very opinionated about what it does and how it does things. There's a deliberately reduced set of transport mechanisms and everything, and of what you can actually transport to really aggressively optimize for efficiency. If there's any translations from other data models into the Prometheus data model, again, this ideally happens in exporters, which are, again, reverse proxies. And what that means is I can scale those alongside with all my workloads, and I can push all of my compute to the edge. Basically, what made the internet successful, of having really dumb, high-performance cores and push all the intelligence to the edge as far as I possibly can. Also automatically means I horizontally scale with whatever my workloads are, because either it's in the code directly or it is sitting close to the code doing the translation, and then the pipeline is super, super efficient. You can also see this, and there we come to the request for spicy takes, the first one. If you look at the Prometheus agent, which is open parentheses for those who know APM. What closed source vendors in APM space call agent is not what the rest of the industry calls agent. For us, an agent is just something which does a job, and that is transmitting stuff. So that's the Prometheus definition. And you have 3.x less CPU usage and 3.6x less CPU usage and 5.3x less memory usage than if you use OpenTelemetry Collector for metrics, which comes from the necessity of like having a lingua franca in OpenTelemetry and like 24 different input and output formats. So it stands to reason why you have this. But this is one of the benefits of having a pure Prometheus pipeline as part of your stack. You just pay less, very bluntly. And then also what you have in the Prometheus ecosystem, and again, we are at the spec or standard thing. PromQL, which Whitney already mentioned, is a query language. It is a functional vector-based language, as in you define your query once, and then you just, no matter if you have one result or 10,000 or 0.
5,
I can't read this.
4,
Oh,
3, 2,
good.
1. Bye,
So
Richie.
now I talk and then you cut me off and
I'm sorry, Richie. Usually Victor's the villain. I don't like being the villain.
Well,
It's- I-
live and learn with me.
I'm turning red. Sorry, Richie. We'll let you. We'll ask you so many questions later and let you be able to say all of the important things. We're gonna bring Austin on next. I have so many questions, so we'll save them. And also, y'all, if you have questions, we'll get them answered from our super duper experts. So please ask them. All right, Austin. Hello. I'm getting my timer going again.
All right,
And
tell me when we're ready.
I'm going to put your thing up, and here we go. 1, 2, 3.
All right, so hi. I'm going to spend 5 minutes and probably change talking about OpenTelemetry. And rather than kind of just tell you a lot of things, I want to show you a couple things too. Fundamentally, OpenTelemetry is a project which is designed to provide what it says on the tin right here, right? High quality, ubiquitous, and portable telemetry to enable effective observability. Now, what does that actually mean in practice? I know some people in chat have said, OpenTelemetry is vendor agnostic. I've heard a lot of people around the community say, it provides this standard. And how we do that is through a very specification-driven set of work to define kind of two parts of this layer of these stack, right? And if you think about observability, what is observability? It's the ability to kind of see what your system is doing based on its outputs. Now, to do that, to actually implement that in practice, you need all these things. You need the telemetry. You need data pipelines to transform and control that telemetry. You need a database to store that in. You need a language to query that telemetry in. You need tools to help you project those queries into visualization so that humans can understand them. And finally, you need workflows built on top of all of that that actually let you as human beings kind of translate those insights into useful actions, like improving system performance or something else. OpenTelemetry very specifically does not have a ton of opinions about anything above that pipeline step. We are very tightly focused on the telemetry data itself and how you get it out to the rest of your observability stack. So I'm going to show you a couple different tools here that are going to be using things like Grafana, Jaeger, Prometheus, so on and so forth, because all of those are higher level concerns to us. So what we have is we actually have this demo you can go get off of our website, OpenTelemetry.io. And this demo is actually a full end-to-end implementation of a microservices application that is instrumented with OpenTelemetry. So if I want to, it's a pretty standard e-commerce type thing. I maybe want to go buy a telescope. That looks like a cool telescope. I could order it. Oh, what about this one? Oh, something's wrong in my application. I'm not getting, something here. Like there's nothing going on. What's up with that? This is a common occurrence if you're an SRE, if you're a developer. And with just things like metrics, right? Just things like logs, problems like this, which occur many times a day, can be difficult to track down. If you just have metrics, then maybe you're going to go and jump into Grafana or something. You're going to look through all your metrics and try to find something that correlates to it. Perhaps you have alerting set up. And that can be great, but what you often find is something like this. You have a dashboard, and you said, well, that's some sort of front-end problem. I jump into my front-end dashboard, and I see, like, well, there is this high level, this error rate is increased here, but it doesn't really give me a lot else to go on. My next step would be going in and looking into logs, but maybe I don't have logs in the front end because they're coming from, they're getting put into a different system, some sort of crash or error catch system. It's tricky, right? Like these are sort of the class of problems that you're having to deal with trying to investigate anomalous behavior on your application or service. OpenTelemetry gives you a couple of interesting ways to solve this problem or to tackle these challenges. And one is the fact that OpenTelemetry very deeply has this idea of context. We are built on top of technologies like distributed tracing, and we allow you to correlate very easily metrics, traces, logs, all of these sort of signals together. Now, not all of that works in every application, and you do have to set some of that stuff up yourself because, like I said, we're not super opinionated about everything above that pipeline step. But in my demo, I can see here that, yeah, I do see a lot of requests going to the front end, and I do see there's a lot of front end errors, but I also see there's this interesting set of errors coming from the product catalog service. I can use that knowledge and jump over into a tool like Jaeger, which lets me look at distributed traces, so end-to-end requests through the transaction, and jump into one of these and say, like, okay, well, I do see that here's some errors up in my front end. Internal server error 500, great. But if I go looking for that thing that I just looked for and lost.
20 seconds.
I can see down here, there's my product catalog service. And in here, I see that I have an error on this specific product ID, right? Then I could take that information, go into my code, find the actual issue, track it down, and fix it. And that is kind of the goal of OpenTelemetry, to give you that kind of really high-quality data in a standards-based format for you to use in your own debugging and observability scenarios.
Perfect.
Wow. I think my way is meaner than your way of ringing a gong. I don't even get to.
Yeah, you just cut off. You don't even give them opportunity to finish the sentence.
I don't even say goodbye or anything. It's terrible. It doesn't make me feel good.
Now I understand why you let me do it, because you're more evil than I am.
I guess. I'm just trying to. I don't have a gong. Maybe I'll get one so I could say sorry, goodbye while I'm making a lot of fuss. But that was very helpful. I'm going to bring everyone back on and we're going to ask some questions. Y'all, thank you so much for sharing your time and expertise with us. I appreciate you very deeply. So off the bat, there are two kind of like level setting things I want to go over before we dig into the questions. One is I want to have a good definition of what observability is. Like, what are we all together trying to achieve with our observability tooling? So, Richie, will you start with that, please?
Sure. So the very unvendory and very clean and simple and reducing FUD definition is observability is defined as the measure to which extent you can determine the internal state of a system just by looking at its outputs. The definition is coming from the 60s, from control theory, basically when the seventh who knew the whole production line and everything and knew everything, this model didn't scale anymore. Like, you know, the famous thing from Ford where he got a $10,000 bill for someone sitting in front of a generator and then making a single chalk mark and then challenging the bill and wanting this itemized, and the person sent back making chalk mark $1 and knowing where to make the chalk mark $9,999, and Ford paid. So the thing is, that model of just having people who know everything about the system didn't work anymore, and there needed to be science on how humans can actually understand complex, interconnected, ever-changing systems. And that's initially where observability is coming from. There's more functional definitions, or to me, they're more like tests. Like, for example, if you can only determine that something is broken and not why something is broken, it's not observability. Or if you can not ask new questions on the fly, it's not observability. But again, to me, those are more like tests, not a clean scientific definition of what observability actually means.
That's great. Is there anything you'd like to add, Austin?
I mean, it's going to be a yes and, right? Like, I think one of the things that gets missed sometimes when we talk about the dictionary definition of observability is that beyond the simple, vendors wanting to kind of claim that space, right? Maybe some of you are familiar with the concept of like APM, right? And maybe you even know that there was a Gartner Magic Quadrant for APM, and that doesn't exist anymore. It's now the Gartner Magic Quadrant for observability. And that's been a pretty big sea change in how the industry thinks about these problems in the course of 3-4 years, right? Like, this is a movement, I would say, that's kind of happened pretty rapidly in terms of how much it's been land grabbed by various people trying to sell us stuff. And there's nothing inherently wrong with people trying to sell us stuff that pays the bills. But it is interesting that we've had this, kind of coat of, it's almost just like people throwing a coat of paint on it, right? And I think one thing that gets missed when we get into these linguistic, what does the word mean, is that we don't ask ourselves, like, why do we need a word to begin with? Why do we need this new word? I think a really interesting way to think about this in the concept of software systems is to pull from medicine, right? There's this concept in medicine called safety 1 and safety 2. And safety 1 is sort of this older idea of like patient safety and procedure safety that was designed around the idea of, okay, well, we can enumerate all the things that happen in a surgery, and we can say, here's all the things that you shouldn't do, right? Like, don't do this, don't do this, don't do this, don't do this. And then if everyone follows their checklists, then great, things will be perfect. And the problem with that is it doesn't really matter when things that the people that made the checklist couldn't envision happen, right? Like, you might have your big checklist of like, okay, here's all the things not to do, but then some emergent behavior happens, or you lose power, or the surgeon has a heart attack in the middle of the surgery, and now what, right?
Yeah.
So safety 2 is this reframing of it where it says not, hey, here's all the things not to do. It's like, okay, let's look at all the cases of surgeries and let's look at the outcomes and say, here's the good outcomes, here's the bad outcomes. What do all the good outcomes have in common, right? What are the things, what are the characteristics of the successful surgeries that made them successful? Compare that to what happened when they were unsuccessful. And then try to build this, sort of Swiss cheese model or defense in depth model, or to take something from security, the idea of like zero knowledge or zero trust, where it's less about here's the pre-aggregated list of things that we know can go wrong, so don't do those, and more, what are the things that matter for actually achieving good outcomes? Let's do those instead. And that to me is that is observability, right? Like, in a real world applied sort of environment, it's our ability to make distributed, decentralized, modern software systems run at scale in a way that achieves our goals of like user happiness, but also achieves our goals of like making sure that SREs and developers don't, go mad trying to grep through logs from 10,000 Kubernetes pods.
That's great. And so I want to highlight a comment that leads me to this. I want this question answered. OpenTelemetry is also software, but I also want to expand that question to be, I'd like for each of you to very practically help us all understand which part of your tool is standard, which parts are specification, and which parts are like choices that people can make. You know what I mean? Does that question make sense? Okay, great. Yeah. So, Austin, will you start with this one?
Sure. So, OpenTelemetry is a specification, right? Like, it's not just a specification, but everything starts from the specification. And the specification has three primary outputs. One is the OpenTelemetry API. The API is designed to be a more or less independent, composable telemetry API that lets you do things like define a span or a metric or an event in your code without having any external dependencies on a particular implementation of the OpenTelemetry SDK. The SDK is the thing that connects that API and actually turns those API calls, turns that request to start a span or stop a span or write a counter, turns it into the actual instrument, to the actual telemetry data itself.
And that's then a specification or software or both?
I mean, those are the product of a specification. So those are software, right? Like those are both dependencies that you would take in a service or a library.
Okay.
Now, we also produce other types of software that are not defined in the spec. So one example of that is the OpenTelemetry collector, which is a binary that you can run that is sort of like a Swiss Army knife for telemetry. You point your OpenTelemetry SDKs at it, you point it at your files or your existing telemetry sources, and then it can take them and transform that data. It can, filter out data you don't want. It can remove PII. It can do a lot of different things and send it off somewhere else. Okay. And that is specifically software. Now, it's software that doesn't necessarily care about where you're sending it to, right? It just says, hey, export, you tell it, take this stuff and export it somewhere else. And it says, cool. And then it's, job done. But that's, and then there's a few other things, but we won't get into those.
Back to Bill's question. So which you talked about APIs, SDKs, and the OpenTelemetry collector. Which part of those is like the standard, or like which part is Zipkin and Splunk implementing?
They are implementing the specification, right? So
the APIs?
They're implementing the data model specification. So there's another thing that the spec drives, which is this idea of the OpenTelemetry data model and semantic conventions. And that's something so that when you send data to Splunk or Honeycomb, or maybe you've heard the acronym OTLP, stands for OpenTelemetry Protocol. That is a data model that we define in the specification, and it's very tightly related to the API, right? Because the API is, when you say start a span or create an up-down counter in the API, like that is represented in the data model in a specific way. And then on the receiving end, if someone implements OTLP, implements OTLP, so Splunk, for example, if they have OTLP receivers, then they get that data, that telemetry data, and choose. Then they do whatever they want with it, right? Like once it gets to a database, once it gets to kind of a storage layer, people can choose to reformat that into their existing internal data models. They can do whatever with it. We aren't super opinionated about what you do with it. We have recommendations, obviously.
Thank you. And Richie, same question for you. Which parts, what's standard, what's specification, and what's software?
The standards person in me feels the need to point out that it's not just the data model and the semantic convention, it is also the wire format which OpenTelemetry defines, because else you couldn't be transmitting it over anything.
Yes,
That's
thank
just
you.
me being a little bit OCD.
No, you're right. I used
but-
I used OTLP to refer to both of those things, but yeah.
So the Prometheus is a little bit of its victim of its own success here, because in theory my answer is everything, and at the same time my answer is nothing.
Okay.
So you would be using usually all three parts, or at least two parts, as in either the client libraries or the exporters, or both, and Prometheus. There is plenty of Prometheus compatible backends. Be careful about some vendors making stronger claims than others, and not everyone being able to actually back this up with data or tests. But at the same time, as Prometheus is so successful, you can replace every single part of it if you wanted to. Of course, there are compatible alternatives for pretty much everything, with the exception of most client libraries, I would say. It really depends on what you want to do. So yeah, maybe as one side note on the victim of its own success. So if depending on if you ask GitHub or if you ask Google, at 15K to 25K dependencies or reverse dependencies to the Prometheus client Golang library alone, it is one of the most used Go libraries on Earth. I think it's in the top 10 or 15 or something, and that includes the standard stuff. So it's almost inevitable that you're going to hit it. But in theory, if you were only running exporters and such, you wouldn't need the client libraries, at least not yourself, like they're in the exporters. So yeah, it's a little bit of a non-answer, because it's at the same time everything from end to finish, beginning to finish, or nothing, or anything in between, however you choose.
Excellent. It kind of makes me feel better for not being able to figure it out on my own, honestly.
One question
yeah.
or comment first. So back in the day, when I was young, which was long time ago, right? I used whatever I was using back in the day. It doesn't matter which tools were for observability, right? And then I was introduced to Prometheus for the first time, right? And the thing that completely shook my brain or confused me is, at least to my knowledge, that was the first time that I found out about the tool that said, no, you're not pushing anything to me. Kind of, there is no agent, there is no code, nothing is pushing to me, I'm going to pull stuff. Which was, at the time, afterwards I learned about it and what's not, at the time was very confusing. Like, why? So, why? I mean, I'm not claiming that no other tool of similar kind was pulling, but at least for me, that was a relatively new concept. So, why pulling
pull?
instead of pushing? Yeah. Or versus, or however you want to explain it.
I mean, versus. So push versus pull is a near religious debate, and you can largely map them onto each other. The two or the three. No, let me restart. So, speaking from a networking person, it is provable that pull will have a shorter time to knowledge about the state of your system. So the time between whatever is happening and you confirming positively, on average, in the worst case, that something is in a certain state is shorter and more reliable with pull. It also makes the overall complexity of your system easier to judge, because you are shoving the state where it should belong, which is in the workloads as far into the horizontal scaling as you possibly can. Whereas with push, you are somewhat cheating and just yeet the data to whatever. And it's the problem of someone else to rebuild the state, the pipeline and or the database. You actually carry this work with the workload and have a better distribution of the whole thing. It also allows you to do something which in Prometheus land we call service discovery, and which in OpenTelemetry land has actually been rebuilt because it is so useful and so ubiquitous within Cloud Native. There, I always have a certain view of whatever it is I'm running. And some of this is globally true and some of this is locally true. The software version of something or the Git hash of whatever I compiled or whatever, like that kind of thing is globally true. Whereas the team name, deployment, region is oftentimes only locally true. At least in a general case, it cannot be globally true, it is locally true. So there is built into Prometheus of, on the one hand, having globally true stuff in the itself, as in, for example, the Git hash or whatever, commit hash, and local stuff like the instance name is in the service discovery, as in this is in the actual tooling for observability. So if I now need to change the deployment state or the from staging to production for this and that binary or this and that instance or what have you, I don't need to redeploy the configuration to that binary. I don't need to rebuild it. I don't need to restart it. I don't need to reload the configuration, whatever. I do this centrally in my monitoring or in my observability tooling or whatever. I can also, for example, have a different view of the world in my local laptop, and I just grab the same data, but I put different data onto my thing. It also allows me to do things like synthesizing an up metric, which again is a state of, or is a determination of what state the target is in, a lot easier and a lot quicker. Also staleness, like how old is the data, is it still valid? All of those things are much easier to do. And another point, but I forgot. Yeah, you can rebuild this in push, but it's going to be harder and it's going to be more expensive. Of course, basically, you drop some state and you need to rebuild it somewhere else. So the overall effort is actually higher, even though the effort on the local binary might be lower. But like the end to end is higher with push.
Austin, do you agree?
I mean, I think that I'll agree that pull versus push is something that people approach with a near religious fervor, and we're not going to convince anyone of things that they're not already convinced of themselves today. I will say that it is like anything else, trade-offs, right? I think broadly, I think the Prometheus scrape model makes a lot of sense for certain types of metricized data, and it makes a lot of sense, the way that Prometheus is implemented. I think, Kubernetes applications especially benefit a lot from the simplicity of the pull-based model for Prometheus scrapes. And this is one of the reasons that OpenTelemetry and Prometheus, are designed to be highly interoperable and work together very well, because we recognize that there is, no one answer for everyone. Now, on the flip side, there are things about push that are really nice, and there's some unique challenges. There's some things that we can do in OTLP and in specifically OTLP metrics push that are pretty differentiating. I think it's just a challenge of we have done this thing and we kind of need people to adopt it, right? And the biggest one I would say is that we have this system of that you could characterize as what I call semantic telemetry, right? The shape of an instrument means something in OTel. And part of the reason that it does is because we provide this way to losslessly reaggregate and transform metric data through something called views at the process level, and also again at the collector level. So basically both. At the time the telemetry is, at each cut, you can kind of take telemetry and transform it in ways, and then be able to revert, to do that in a non-lossy way, which opens up a lot of opportunities for example, being able to remotely change the aggregation of certain metrics in real time based on signals from further down the line. It also means that because we connect all this stuff up through this idea of context, distributed context, right? So your traces, your metrics, your logs, everything is really highly correlated in OpenTelemetry. So you could see a world where, metric data is being processed somewhere, pushed somewhere, or even pulled somewhere, but it's being pushed somewhere, And then a sampling algorithm there is able to look at that data and say, like, okay, I need to actually adjust the views for this metric data from this particular pod or this particular group of services because of something I'm seeing, and be able to kind of do that on the fly without necessarily having to push that authority to an upstream component, a component upstream of where the data is generated. There's sort of a third class of things here, which is around auditability and guaranteed delivery, which, again, there's ways that you can kind of get guaranteed delivery on scrape, but it's easier and more verifiable to do it through push. So I don't think it's one or the other. I think you can kind of solve a lot of problems either way. I think that at the highest level, if you are doing a bunch of fairly low cardinality metrics across a fairly, heterogeneous class of computing services, where the amount of things you want to know is pretty small, but the number of those things you want to know is very large, and you have the infrastructure for it, and you don't have to necessarily deal with super high cardinality, then the Prometheus model is really, really good. I think for certain other things, the OTel model works a little better, and it's really going to be up to the community to kind of figure out what works better for them. Like, I think there's other stuff we do in OTel around, for example, our exponential histogram implementation is designed to scale very well. But, it's not necessarily a competition. I don't really see it as a competition.
I think, yeah, you're likely to use both. But Richie, I see you shaking your head some. So do you want to state some opinions?
Kind of.
Yeah.
So first, I forgot the last benefit of pull, Thundering Herd. If I have massive restarts, and if I am in a pull-based model, I can actually back off of ingesting too much data and killing the backend. And I mean, this is also maybe something which you see, or not maybe, something you see in the design of the two approaches, where Prometheus also has storage and retrieval and analysis and everything in scope, and we define the whole pipeline and everything as our scope and problem domain, and don't basically define storage and such out of scope. Cardinality has nothing to do with push versus pull. It's just a transport, and it's proven that you can do either for either. On the robustness, again, speaking as a networking person, I strongly disagree. It is more robust to do pull in the generic case. You can always find special cases, and if you have super short-lived processes, yes, pushing is more resilient, but then you only open the discussion of, well, actually the cloud providers should be doing this in the hypervisors because they have the infrastructure for assigning certain workloads and certain users, and they have all the infrastructure to forward all of this information, else they couldn't bill you. But they much prefer you have all of this in your workload, so you pay double. But the on a very fundamental level, pull is guaranteed in the generalized case to be more resilient and slightly quicker about determining the actual state of a system. But you wanted this to be spicy. So
no, I will agree with you in terms of speed. Yes, like I think that pure pull does beat it out in the generalized case. But I also, I think this is one of those things where, from an OTel perspective, you actually got it in the first one, where if you actually do control that entire stack, then you can make those kind of optimizations. They're not really even micro optimizations, right? They're like pretty big ones. I think if there's enough demand for it, you could see changes to, a pull OTLP for certain signals in the future, or we just continue to align like the Prometheus concepts and the OTel concepts to, allow for the more advanced or the more semantic types of counters and up-down counters and all that sort of stuff. But this is getting like super in the weeds. I will say, I think the Prometheus community and the OTel community have actually done a really good job of listening and learning to from each other and trying to combine the best ideas from both, even though, we're in the same space, but we're not necessarily playing on the same. We have, subtly different goals, but the people that we're eventually serving, right? All of you listening to us, like, we're trying to make it all better for you. So even though we're kind of on parallel tracks sometimes, we do try to spend a lot of time talking to each other and figuring out the best way to move forward together for the good of, the entire observability and cloud native community.
I love that. So we have quite a few more questions,
Yeah.
but we're hitting the hour
Let's
mark.
do a lightning round, kind of like 5
lightning
second
round.
answer to questions.
All right.
Yeah.
Okay, so Richie, during Austin's talk, Austin talked a lot about the importance of correlating different signals and how that he was demonstrating how that's going to help him find problems more quickly than just using metrics purely. Will you speak to how Prometheus works with other signals, or is it meant to, or interoperability between Prometheus and other signals?
Yep. So the data model, for those who don't know, of Prometheus is basically you have a name of a metric, and then you have labels, which are just key value pairs of whatever you care about. Deployment equals prod, whatever. And then you have the value. So you can use the same for logs and for traces. Now we are back in the standards. Like, this is not super. Cut me off if it's too long. When I started the Open Metrics thing, actually Google reached out about potentially merging Open Census and Open Metrics. Didn't work out. Open Tracing and Open Census merged into what is now OpenTelemetry. And I told them the story of wanting to have a standard for metrics, and they said, yes, makes sense. And I told them I want to have the same for logs, and they were like, yep, makes sense. And for example, Loki implements this. And then I told them I want to have the same for traces, and they told me, no, searching for traces doesn't scale. When Google tells you searching for something doesn't scale, they probably did the math. Without going into the weeds, that's too much. For the correlation of traces, there's actually something different in Open Metrics / Prometheus land. It's called exemplars, which is basically stolen from Google. It's just IDs which point to a trace. So you don't have this problem of I have a trace, maybe I sample it away and I click on the thing and it's gone away. Or I need to onboard myself into 20 different traces and look for the one bug which I have. Exemplars are a way to attach IDs for traces and or spends onto metrics, onto logs. So I have this and that HTTP 500 error, and I know for a fact if there's an exemplar attached to it, that A, it's not sampled away, and B, I know that this server error is somewhere in this trace. Similar, I have a high latency bucket, whatever. Side note, native histograms between Prometheus and OpenTelemetry are 100% compatible. It's literally the same implementation, and we work together on this. I have my high latency bucket, and I want to jump into something which took 2 seconds. I see an exemplar attached to this high latency bucket. I click on it. I have the confidence, yes, it is there. It's not sampled away. And I'm immediately onboarded. I know for a fact that this thing took 2 seconds to do whatever. I know what I'm looking for, and I know it is in there in the trace. So that's the correlation model in super short of Prometheus.
Excellent. And then Austin,
Fast lightning round.
one of Richie's main points was that Prometheus is more efficient. Can Prometheus be the metrics part of your OpenTelemetry, otherwise OpenTelemetry solution? Or we speak to that overall?
The thing with OpenTelemetry in general is that, yes, there's a reference implementation of the SDK, but there's no reason that you have to use that one. We haven't seen a ton of people go through and re-implement that yet, but if you wanted to create like a stripped down one that prioritized performance over, completeness of the spec, then that's totally valid. And I expect that we'll see more of that as time goes on.
Cool. Good, fast answer. So this question, someone's thinking about switching vendors without having to re-instrument everything. I think I'm interested in instrumenting application code. Do developers have to instrument their application code for each of the types of telemetry data, logs, metrics, and traces? Do they instrument it 3 different times for 3 different ways?
I can take this one. I think both Prometheus and OpenTelemetry have a a lot to kind of help you get started here, right? Like there are Node agent and various other. Richie talked about like Prometheus agents before, right? And being able to easily translate kind of existing critical metrics into Prometheus format so they can be scraped and processed. OpenTelemetry similarly has some, if you're in Java, there's a Java instrumentation agent that looks a bit more like maybe what you conceive of as an APM agent that you add to your command line, you drop it in, and now you'll start to get, traces and metrics and logs from your service.
Micrometer. Yeah.
Yeah, similar to like Micrometer, right?
Okay.
And we offer that in, Java, .NET, Python, Ruby, PHP, so on and so on and so forth.
Okay. And then does it need re-instrumenting ever if you change anything?
No, that's part of the idea, right? Is that same instrumentation will work, if you're sending your data to Grafana, if you're sending it to, Loki or something, to Datadog, to Honeycomb, to OpenSearch, to Elasticsearch, whatever, right? Like it's all anyone that supports OTLP or offers a exporter from the collector to their format, you can just use those OpenTelemetry agents with. And that also means that if you're writing custom instrumentation against the OpenTelemetry API, that will work in all these vendors as well.
Amazing. All right, Richie, this one's for you. Someone Xeralis replaced their Prometheuses in favor of OTel collectors with a target allocator, directly pushing to Mimir. So the question is, will vanilla Prometheus deployments gradually disappear?
So Mimir is not only Prometheus-ish, it is, alongside Thanos, one of the ones which is actually 100% compatible with Prometheus, period. I don't think so. So with my Grafana hat on for a second, we are the main sponsor for Prometheus. Pretty much all the features you saw in recent years have been sponsored by us, directly or indirectly. We have zero intention of competing with Prometheus with Mimir. Mimir is intended as a horizontally scalable, super high performance query path for your Prometheus metrics. It is not intended to compete with Prometheus. On the contrary, we were actually, like again with my Grafana hat on, actually the ones who initially kickstarted first the Grafana agent and then spun out into the Prometheus agent once we had proven the technology. So it is very much a story of coexistence, and a lot of the features which we actually, again, Grafana had, want to put into Mimir, we put into Prometheus first and have all the hard and all the tedious and long upstream discussions before we even put it into Mimir. We basically implement it in Prometheus and pull it into Mimir to make certain that we remain compatible and don't kneecap each other or anything.
Amazing. And did you, on the last question, did you want to add a quick thought about instrumenting applications?
Sure. So both Prometheus and OpenTelemetry are not locked into any vendors. So either or, if you were to put your data into this pipeline or start emitting it natively or whatever, it is an open standard, both of them. As such, you will not be locked into any vendors. Vendor implementations differ for the backends and everything, so you need to be careful there. But for the actual pipeline and everything, you're not locked in.
Excellent.
To Austin's point, because he said, as far as he's aware, there's no re-implementation yet of any of the client libraries. The Prometheus Java client library actually is able to both emit fully compatible Prometheus or OpenMetrics and fully compatible and compliant OTLP. So you can actually flip this if you so choose.
That's the Prometheus client library?
Yes, Java,
cool.
Only the Java at the moment. Prometheus client library is fully OpenTelemetry compatible. We are exploring this for the others as well. Not there yet. But maybe as a side note, and this is maybe also, again, the overhead of having 20 different languages versus only one. If you compare, you'll usually see that the client libraries use less boilerplate on the Prometheus side because we need fewer things, because we are not as versatile. We are allowed to be more opinionated about efficiency.
Excellent.
Yeah, and that's totally fine, right? Like I honestly expect there to be a lot more of that. I do want to, I think I feel like I've actually seen like a couple of other like JavaScript frameworks implement their own like smaller or more constrained SDKs to work within some of the limitations of that platform's runtimes. But yeah, like it's totally cool as long as that's why the API is designed to be kind of slim, because we want people to re-implement the SDK if they need.
This next question, Austin, was about your demo. Was it Jaeger query with Elastic backend?
No, I think for the demo we just use we use the Jaeger all-in-one image, so it's whatever Jaeger comes with out of the box. But obviously, if you go to OpenTelemetry.io and go to the docs and the demo section, you can find the GitHub repo, and there's a bunch of vendors and other sort of people in the space that have kind of created a fork of the demo that works entirely on their platform. So I want to say there's like a Grafana-ized version where everything is going into, it's not just Grafana, it's like Grafana and Loki and maybe Mimir and da-da-da-da-da. So you can explore how those, are different from each other.
Awesome.
It's also a great way to just kind of learn about like how OTel works under the hood. So if you want to see what it looks like to, we try to be very broad in the demo. So we cover like, here's how to instrument manually, here's how to instrument using the agents, here's how to instrument using various libraries. And in the future, we'll have even more.
Cool. All right. A quick answer, speed answer from both of you. A note about scaling. Let's start with you, Austin.
I mean, having talked to people that are running the collector at scale, I think you're going to get very different opinions based on what your concept of scale is. There are certainly teams that are running, tens of thousands of collectors, and in those cases, the problems are a lot more about collector management. We do have some specifications and standard libraries around agent around collector management that are, unfortunately, there's not really a great open source tool that leverages those. I think, there's some we do benchmark the collector. Performance is fine. It could always be better. I know I've talked to people at, for example, Google, who have very different concepts of scale than I do. And they're like, why don't we rewrite this in Rust? And I'm like, well, you could. I think for most people, it works pretty well. There are things you can do to make it more efficient. One great option is something we have called the Collector Builder, which allows you to create sort of a version, a instance of the collector that just does what you need it to do, so it doesn't have as many other things. But you always have to kind of see. I know I have seen talks actually, and if you go look it up on the CNCF YouTube, you can check a couple years ago, a year or two ago, at Observability Day. I want to say the North America one last year, there was a talk about how someone migrated from like FluentBit to the OTel collector and found better performance. There's also been a couple of talks at Observability Day, people doing benchmarks on the collector. So there's data out there if you'd like to go peruse it. I would say overall, it's not bad. I think it's fine for most people, and usually I find when people have performance considerations around OTel, they're actually more at the service level because of the aforementioned, like the SDKs are pretty big. They're doing a lot of stuff.
Excellent. And Richie, do you want to make a note about Prometheus and scaling?
Sure. I mean, as I said initially in the 5 minutes pitch, you are going to be seeing between 3.5 and 5.5x in overhead of the OpenTelemetry collector metrics pipeline versus Prometheus agent. Again, that's just because it's more opinionated and allowed to be. As to scaling, one of the largest banks, a name everyone here certainly has heard of, is running on the order of 50,000 Grafana agent. Well, it's now called Grafana Alloy, long story, but basically a combination of the Prometheus agent, of a variety of Prometheus exporters, of Promtail, which we use for logging, and of OpenTelemetry collector components, all of this meshed into one. And again, like medium number of tens of thousands of instances, and it's just working.
Cool.
Agreeing with Austin explicitly, at this scale, fleet management is your main concern, where there is vendor-based solutions, like for us, for example, but also thinking about pushing this more into OpenTelemetry to have one standard and not two.
Wonderful.
It's definitely something that we've talked a lot about in OpenTelemetry, is having some kind of like, here's what you should do. And it's really just a question of prioritization and not enough people to come in and do the work, right? So if this
Nice.
sounds great, then pull request welcome.
All right, this last question's for you, Austin, and then we'll do our closing statements and say goodbye. So does the OTel SDK automatically receive and retransmit trace IDs in a REST service?
Yeah, if you, we have instrumentation libraries for most popular HTTP clients and servers. So, let's take a simple example, or not simple, but let's take a conventional example, like a Spring application in Java. If you hook in the Java agent there, then it will automatically instrument all of your API routes, and it will handle context propagation for you, just out of the box.
Excellent. So let's do our closing statements. Richie, will you please stay 1 or 2 sentences for why, if we were voting, which we're not, but if we were, why we should vote for Prometheus?
You can't do cloud native metrics without Prometheus. And you can't do cloud native traces without OpenTelemetry.
You just took care of both closing statements.
Thanks. Made my life easy. I would go so far to say is you cannot do cloud native observability in general without Prometheus and OpenTelemetry.
I love it. Awesome. Well, thank you both very, very much for sharing your time and your expertise today. Goodbye.
Thank you.
We did it. That was really fun. I had a great time.
Yeah.
If we were voting, we have a You Choose channel on the CNCF Slack workspace. Disregard the vote part. But if you do want to go, if you want to have ask more questions, or if you have any questions or comments or want to talk to Victor or me, go ahead and post in the You Choose channel. That's where we'll be. And is there anything else we should say in closing? Oh, I have something.
No, I think that the last sentence was critical, really, about, you need Prometheus for metrics and you need OpenTelemetry for traces. There you go.
You're captive. So next week on You Choose, it's going to be next Tuesday at this time, we're going to talk about metric solutions. So we're going to talk about Prometheus again, but we're going to talk more about the software part and less about the standards. We're also going to talk about Thanos and Cortex, and looking forward to that next week. And we'll see you then, friends. Yeah. Goodbye.
Oh, I should press the button.